Hello students, welcome to Learner's Planet, Theory Session 6 of Metals and Non-Metals. In our previous session, we discussed the chemical properties of non-metals, that is, their reaction with oxygen, their reaction with hydrogen and water. Right? Now in this session, we will be discussing few more chemical properties of non-metals. Like here, our first property is reaction of non-metals with dilute acids. Right, children? Non-metals do not react with dilute acids as they form negative ions by accepting electrons. In my previous session, I told you that these non-metals, they are forming what type of ions? They are forming negative ions, right? Like your oxygen, it is accepting 2 electrons, and children, it is forming what? It is forming oxide ion, right? That is O2 minus ion, that is oxide. Now in this case also, as was the case with water, that for the release of hydrogen ion, what is required? It requires electrons. Now your non-metals, they cannot give electrons for reducing what? Hydrogen ions of acids and convert them into hydrogen gas. Right, children? So, in this case also what will happen if I take any of the acids, like I am taking dilute HCl. Right? Now what does dilute HCl will give? What type of ions this dilute HCl is going to give? They will give H plus and Cl minus ions. Right? Now for hydrogen ions to be released out as hydrogen gas, what it requires? I told you it requires electrons so that it is released out as hydrogen gas. Right? Now these non-metals, they cannot provide electrons, so the hydrogen gas cannot be released from acids. But in case of concentrated acids, children, like concentrated H2SO4, concentrated nitric acid, they are what? They are strong oxidizing agents. Okay. Now they will oxidize the non-metals, like your sulfur. Sulfur is oxidized to sulfur dioxide, right? By what? By an acid, that is a concentrated nitric acid HNO3 or concentrated sulfuric acid H2SO4. Now these both acids, they act as what? They act as oxidizing agents. Okay, and your non-metals, they do not react with dilute acids. Remember this point clearly, because many a times equations like this are given, that is sulfur plus HCl, which is dilute, right? And it is giving you H2S, or yeah, the equation can be plus Cl2. So this reaction is totally wrong, children. Sulfur plus HCl dilute, there will be no reaction. Right? So you must remember this point so that whenever you are solving some objective type of questions, you can mark it as no reactions. Right? Now let's move to the other property, that is, children, reaction of non-metals with salt solutions. As we did with metals what they do? Metals are arranged in their reactivity series. Remember that how were they arranged? Metals were arranged in the reactivity series like this was potassium, the most reactive, then was the sodium, then was your calcium, then aluminium, Then was what? Zinc, iron, right? And there was hydrogen, and below there was copper, silver, gold, right? So this was metal reactivity series. From this you can very well guess that metals lying below will displace them from there, will displace the metals lying above in the reactivity series will displace metals lying below in the reactivity series from their salt solutions. Now in this case of non-metals, there is no such reactivity series. So how we will get to know about the reactivity, right? The reactivities of non-metals can be understood from their positions in the groups. Like let's take up the periodic table, that is how they are arranged. If I am taking group 14, what all elements are there in group 14? It is carbon, silicon, germanium, tin and lead, right? Group 15, it is nitrogen, phosphorus, arsenic, antimony and bismuth. Group 16, oxygen, sulfur, selenium, tellurium and polonium. Group 17, fluorine, chlorine, bromine, iodine and of course astatine. Now the last element, children, this astatine, it is radioactive. Now in this case, children, what happens? That the reactivity decreases down the group, right? So it is reactivity of non-metals is decreasing. I'll write reactivity decreases, okay, of all these non-metals. So in case of non-metals, the reactivities are decided from their positions in the periodic table or in the group. So in this group 17, which would be most reactive? Fluorine. Least reactive? Iodine, right? So the non-metals or the elements lying above can replace the elements lying below from their salt solutions. Like example, which salt solution is this, children? It is sodium iodide, right? It is reacting with bromine. Now I can just check out from the group, from the position in the group. Which is above? Bromine. Which is below? Iodine. Which would be more reactive? Bromine. So what this bromine is doing? It is replacing iodine from sodium iodide. Clear? I can also write as an equation as 2NaBr, that is your sodium bromide, plus Cl2, that is your chlorine. Okay, so which is more reactive? Just check out from the reactivity series. Chlorine or bromine? Which is lying above? Chlorine is lying above. So chlorine is more reactive than bromine. So what will this chlorine do? Chlorine will replace bromine from its salt solution, right? And it will form 2NaCl plus Br2. Right? So in this case it happens like this. Okay, children? So now any case the salts with the non-metals, they are formed by group 17 only. Okay? Now let's move to the next slide. Right. It is the next property of non-metals and that is very important. It is reaction of non-metals with halogens. How they react with halogens. So your group 17 elements are called as what? Halogens. So your tin reacts with chlorine forming what? Stannic chloride. What will be the formula of stannous chloride, children? Stannous chloride would be SnCl2. Is what? Stannous. chloride. Okay. Likewise, phosphorus P4 is reacting with chlorine and forming what? Phosphorus trichloride. One more chloride phosphorus forms, that is phosphorus pentachloride PCl5. This is what? Phosphorus pentachloride. As the name indicates, what will be the formula of phosphorus pentachloride? PCl5. Likewise, large number of halogens or halides are formed by non-metals. Okay? Oxychlorides are also formed. Oxyfluorides are formed. Right? Oxychlorides are unstable. So what are formed is oxyfluorides. OF2, O2F2. These are what, children? These are oxyfluorides. Right, and they are named as oxy. So these are some of the chemical properties of non-metals. Okay, now let's check out how about the existence of metals, or let's check out about the properties of compounds formed by both non-metals and metals. Right, so what these non-metals, what type of compounds are formed by non-metals? They are covalent as well as ionic, right? Now let's see what are covalent compounds and their properties. The atoms of elements are bounded by covalent bonds, right? I have already discussed in my previous session, covalent bonds are formed by sharing of electrons between atoms of elements. Okay. Now these compounds, children, they are usually liquids or gases. Like H2O is a liquid, HCl is a gas. Okay. So these compounds are usually liquids or gases. Ammonia exists in the form of liquid as well as in the form of gas. H2O2 exists in the form of a gas as well as in liquid. There are only certain covalent compounds which are solids. So covalent compounds which have solids are very rare. Right? These compounds have low melting and boiling points. Now children, I told you that your melting and boiling point depends on what? Melting and boiling point depends on intermolecular forces of attraction. Right? Attraction. So, more is the intermolecular force of attraction, more will be the melting and the boiling point. Right? So, in this case, what is their physical state? It is either liquids or solids. So, they will have what, children? They will have low melting and boiling points. Okay? Let's see few more properties of covalent compounds. Like, these compounds do not conduct electricity. What I told you was, what are the carriers of currents? Carriers of current. What are they? They are either ions or electrons. Right? Now, can covalent compound form ions? No. So how can they be conductor of electricity? They are the non-conductors of electricity. These compounds are usually insoluble in water, except organic compounds like glucose, alcohol, urea. Right? So the covalent compounds are insoluble in water. Now these glucose, alcohol and urea, they are also covalent compounds. But these are organic compounds, and all the organic compounds are to some extent soluble in water because of the formation of hydrogen bonds. Okay, So for a compound to be soluble in water, it should form a hydrogen bond or it should form a compound with water, right? So organic compounds like glucose, alcohol, urea, they form hydrogen bonds with water. This type of bond I'm definitely going to discuss in your 11th session, okay? Now these compounds are soluble in organic solvents like these compounds like your ammonia or HCl or phosphoric acid or phosphorus pentoxide or PH3 or sodium hypophosphite or ammonium chloride, all are soluble in organic solvents. Right? Ammonium chloride is a salt. It is soluble in water. So these covalent compounds are soluble in organic solvents. Organic solvents like, what are organic solvents? Like benzene, right? Benzene is an organic solvent. C6H6, benzene. Toluene, these are all what? Organic solvents. Right, children? Now let's take up some of the properties of ionic compounds. The atoms of the elements are bonded by ionic bonds. I have told you what are ionic bonds, right? Ionic bonds are formed by transfer of electrons from one atom to the other. Right? So how it is formed? It is formed by the transfer of electrons. Now these compounds are usually crystalline. What type of shape they have? They have a crystalline shape. They are in the form of crystals. These compounds have high melting and boiling points. Why? Because the ionic bonds, they are very strong bonds. Okay? So I'll write here why. Because ionic bonds are very strong bonds. Clear, children? So your covalent compounds have what? They have low melting and boiling points, whereas ionic compounds have what? They have high melting and boiling points. Why? Because the ionic bonds are very strong bonds. Okay, so there are few more properties of ionic compounds, that is, these compounds conduct electricity when dissolved in water or melted. Okay, so the ionic compounds, what they will give in water, like your NaCl, what it will give out in water? It will give out ions in water. So when it is giving out ions, it can conduct, these are what? These are charged particles and these can conduct electricity. Okay, like your CaCl2, this is also giving what? This is also giving out ions like Ca2 plus 2Cl minus. So for our compounds to be good conductor of electricity, what is required? Either the electrons or the ions. Right? So the ionic compounds conduct electricity when in dissolved or in molten state. Your dry NaCl will not conduct electricity. Dry calcium chloride will not conduct electricity. Right? Because they are not forming ions. These compounds are soluble in water. They are also soluble in water because they will move into water and they will form what? Ions. Okay? These compounds are insoluble in organic solvents like alcohol, ether, acetone as well as benzene. Right, children? So these are some of the properties of ionic compounds and the covalent compounds. Okay? Now let's take up the metals, about the occurrence of metals, where and how these metals occur. So it is, metals occur in nature in free as well as in combined states. Got my point? So they can exist in free as well as in combined state. Now those metals which are least reactive and have little or no affinity for oxygen, that is, which metals are least reactive, children? The least reactive metals: gold, platinum, silver. What are these metals? These are least reactive metals, right? Now they have very little affinity for oxygen or moisture or other chemical reagents. So how can they exist in nature? They can occur in free, metallic or native state. Clear, children? That is in uncombined state. You can get silver as it is. Silver is not combined with any of the non-metals, or it is not forming any of the compound. There is only one compound of silver form, that is horn silver. That is, it is an ore of silver, AgCl. This is called as horn silver. Ag2S is silver glans. But most of the times what happens that your silver exists in the native state. Gold also exists in the native state, and platinum also exists in the native state. Why? Because these are least reactive. Okay, and they have no affinity for oxygen, moisture and other chemical reagents. Right? You must be knowing why they are least reactive. Because they are placed below hydrogen in the reactivity series, and that too at the bottom. Okay. Now most of the metals are reactive and hence are found in the combined state, that is as compounds. If I am taking example of sodium, it is highly reactive. Potassium, highly reactive. Aluminium, it is also reactive. Magnesium is also reactive. Got my point? So, as these are very reactive metals, so they are found in their combined state. Right? It is about minerals and ores. What are minerals and what are ores? The natural substances in which metals or their compounds occur in the earth are called minerals. Just now I told you. What I told you was that the metals which are reactive, they exist in combined state. Combined state, that is in the form of their specific compounds. Okay. Now, minerals are what? These are the natural substances in which metals or their compounds occur in earth. Because you can't find sodium just lying in the earth crust. Otherwise it will react with oxygen, it will react with moisture and explode. So it is formed combined with some other compound because it is highly reactive. Okay. Now these are called as what? Minerals. The minerals have a definite composition. Now children, here you can't say that it is a mineral, so it can be NaCl2 or AlCl4 or FeO. These are like they have got a definite or fixed composition. The composition is not changed. Right? Now children, it may be single compound or a complex mixture. It may exist as a single compound or large number of compounds can exist with it. Like your wolframite ore is there, that is Fe2O3. It exists with SnO2, that is tin oxide, stannous oxide. Okay, so this mineral can be either exist as a single compound or it can be present as a complex mixture. Now the minerals from which the metals can be extracted easily and economically are known as ores. So children, there is a difference between minerals and ores. What are minerals? Minerals are the natural substances in which metals or their compounds occur in the earth. Okay. But ores, what are ores? Ores are those minerals from which metals can be extracted. So you can't say that from every mineral metals can be extracted. There are only few minerals from which metals can be extracted. So it can be concluded that all ores are minerals, but all minerals are not ores. So this can be a one-liner. It can come in the form of a fill in the blanks or true or false or objective type of question. So remember this, all ores are minerals, but all minerals are not ores. What are ores? These are the minerals from which metal can be extracted. Right? Now let's take up few examples of ores, or first let's see metals which occur in native state: gold, silver, platinum, mercury. These are usually found associated with rock or alluvial materials like clay or sand. Okay? Lumps of pure metals are called nuggets. So what are these lumps called? These are called as nuggets. Right, children? Now let's see few ores. Some important ores of common metals like sodium. The ore of sodium is rock salt, that is NaCl. NaNO3, sodium nitrite. It is also called as chili saltpeter. Okay. Na3Al(F6), it is cryolite. Similarly, the ores of calcium, it is children gypsum. CaSO4, calcium sulfate with 2 water molecules. I had told you about gypsum in the topic of acids, bases and salts. From gypsum we manufacture what? Plaster of Paris. Do you remember? There is another ore, that is calcium fluoride or fluorspar. Next ore of calcium is calcium carbonate, that is limestone. Right? So these are the minerals, children, from which your metal can be easily extracted. Now next is magnesium. The ores are magnesium carbonate, MgCO3, and CaCO3. I'll write it clearly here. Magnesium carbonate, MgCO3, CaCO3. What is its name, children? Its name is dolomite. Right? One more ore is there, that is carnallite. It is KCl, MgCl2 and 6H2O. This is what? Carnallite. Right? So these are the ores of magnesium. The ores of aluminium, that is Al2O3, 2H2O, that is bauxite. The next ore is cryolite. I have given its formula above also, Na3Al(F6). Right? The next one is corundum. Corundum is Al2O3 is corundum, and diaspore is Al2O3H2O. Right, children? So these are the ores of some common metals. Now I'll conclude this session. In our next session, we will discuss few more ores of metals and the metallurgy of these metals. Okay?